For your second subtopic, it is on electric field. So in this subtopic, you have to be able to define and use electric field strength, use this equation here for point charge, sketch the electric field strength diagram, so maximum 4 charges in 2 dimensions, and lastly, determine the electric field strength for a system of charges, and that is a maximum of 4 charges in 2 dimensions. Okay, so electric field strength, the symbol is E, and it is defined as an electric force that is acting on a test charge which is placed in the electric field region divided by the magnitude charge of the test charge. Okay, so the physical meaning is basically just a region in which an electric force will act on a charge that is placed within the region lah. Okay. The mathematically it can be written as the one shown here. So F is the electrostatic force, Q is the magnitude of the charge lah. It is a vector quantity with the SI unit of Newton per Coulomb. So remember, since this is a vector quantity, we can resolve it into X and Y components lah. And it has directions. So the electric field patterns can be represented by electric field lines, which is drawn pointing in the direction of the electric field vector at any point. Okay. So the properties of electric field lines are as shown here. So it will never cross one another. Never cross one another, and the number of lines determine the strength of the electric field. So electric field lines, the electric field is large when the field lines are close together and small when they are farther apart. A positive and a negative charge can produce electric field. The number of lines entering or leaving a charge is proportional to the magnitude of the charge. Okay, so let's look for the electric field lines for a stationary charge. So for a positive charge, the direction of electric field is gonna be outward. So it will be going out of the charge. Whereas for a negative charge, it will be pointing towards the charge. Okay, so it's going into the charge. So these two directions here are important because this is where you will know how to draw the direction of the electric field lines lah. Okay, so untuk two charges pula, so if we have a positive and negative charge, the electric field from the positive charge will be going into the negative charge. Okay, so this is just how you would draw it lah. So at this point here, when they are closer together, it means that the electric field strength is greater than the one at further apart here lah. Okay, and then for light charges, they will repel each other, so they won't be going into each other, no, because this is this has the same charge lah, same sign, so they cannot go into the charge for positive charge nila. Okay, so at one point here they will be closer together, but they will never intersect with each other. Okay, for this one pula, if you see this part here, the positive charge has a magnitude greater than the negative charge here. So the number of lines going into this charge is so the number of lines is basically just greater than the negative charge here lah. Okay, yeah, right, basically just that, because the number of lines is telling you the magnitude of the charge. Okay. Uniform electric field lines pula. So for two opposite charge parallel metal plates, the electric fields will be perpendicular to the surface of the metal plates. So this is perpendicular lah. So it goes directly from the positive plate towards the negative plate, and the field lines are parallel and equally spaced in the central region, far from the edges but fringe outward. So basically they wouldn't be like this at this point here. They would go something like this, okay, as it goes further near the edges lah. Okay. In the central region, the electric field would have the same magnitude at all points. Value of electric field is always constant, and if you were to draw this, you have to draw at least 3 lines of electric field lah. And then the parallel plates can be horizontal ataupun vertical, like the one shown here. Okay, so that is the sketching of electric field lines. Now, electric field strength for a point charge, let's consider test charge, which is shown here at a distance r from a point charge. So according to Coulomb's law, we have this equation here, and from definition, electric field strength is also written as the one shown here. So when you substitute these two together, we get an equation that is like this, okay? So this equation is the equation that we will be using to determine the electric field strength of a charge, okay? So again, K is Coulomb's constant, Q is the point charge that produced the electric field, and then R is the distance from the point charge lah, from a point from the point charge gitu. Okay, so notice that this electric field strength is actually inversely proportional to R square. So if the distance is greater, the electric field strength will be lower. Okay. So this is just the graph, and then the strength of, based on this graph here, the strength of electric field will decrease when the distance from the point charge increases. So note that the direction of electric field strength depends on the sign of the point charge only. Okay. Okay. So let's look at the relationship between electric field and the force due to charge Q. Okay, so the force on a positive test charge will point in the direction of the electric field. Okay, untuk negative test charge pula, it will point to the opposite direction of the electric field. So basically this would be attracted to this part here, and then since this is both positive, so they will be going away from each other. Begitu je lah. Okay. Okay. So this is Q lah maksud dia, due to charge Q ni. Right. So then we have to solve for example 2 and 3. Okay. So yeah. So this is the what do we call this, the solution lah for solution pula, the theory part for electric field strength. Now we are gonna do for the examples. So for example 1, so this is in 1 dimension saja. So we have to determine the electric field strength at point X at a distance of 20 centimeter from a point charge Q. So first you have to be able to draw the electric field diagram lah. So the direction of the electric field tu kamu perlu lukis. Okay. So untuk point X, where we are gonna draw it is where the question asks. Point di mana? Charge mana satu. So macam tu lah. So untuk point, this is the point where we'll be focusing on, point X. So for now, the electric field strength will be 20 centimeter from a point X at a distance of 20 centimeter from a point charge Q. So first you have to be able to draw the electric field diagram lah. So the direction of the electric field tu kamu perlu lukis. Okay. So untuk point X, where we are gonna draw it is where the question asks. Point di mana? Charge mana satu. So macam tu lah. So untuk point, this is the point where we'll be focusing on, point X. So for now, this is a positive charge. And what you need to remember is the electric field for a positive charge will be pointing outwards. So it will be pointing outwards. So if we focus on this direction, it is telling us that the electric field strength will be pointing to the right, untuk point X, at point X. So this is here, and this is E je lah. So pada satu je pun charge. Okay, so the electric field will be pointing to the right. So after drawing that, we can then solve this. So this is E equal to KQ over R square. So this is just 9, 9, 8, -6 over R, which is 0.2 square. Okay, so this will give you 1.8 times 10 to the power of 6 Newton per coulomb. Okay, so that is the magnitude of the electric field strength lah. Next, the electric force. So force is equal to K that acts on a test charge. So now there's a test charge at point X. Okay, so sekarang ni instead of just point X, there's a charge. There's a charge here, Q naught, which is a negative charge. Okay, so now we just have to substitute lah. You don't have to consider the punya sign because for electric field strength and force, we ignore the sign. The sign is just telling us about the direction. It just helps us to draw the electric force and the electric field strength diagram. So this is 1, -6. Okay, over 0.2 square. So this is equal to 1.8 Newton. Right? Alright, so that is on example number 2. Example number 3 pula, this is on two dimensions. So there are 2-point charge, 7 micro and -5 micro, separated by a distance of 0.3 meter between each other. Determine the resultant electric field strength produced by these two charge at point P. So sekarang ni kita fokus at point P here. Okay, so remember, for a positive charge, it will be pointing outwards. For a negative charge, it will be pointing inwards. So our diagram will be, this one's gonna be pointing here. Aduh, puro. And then we have this one pointing there lah. Okay, so let me just drag this. So this is basically the so this is basically the drawing of the electric field strength punya diagram lah. The diagram macam free body diagram, tapi this is electric field strength punya diagram. So there's gonna be an angle here where we need to find. So this is electric field strength due to charge 2. This is due to charge 1. Okay, so since there is an angle here, this is telling us that there will be X and Y component lah. We have to resolve it with X and Y component. Basically, the solution is two dimensions lah. Okay, so but before that, let's let's determine the magnitude of this electric field strength. So E1 is equal to KQ1 over r1 square. So this is 9 times 10 to the power of 9. Q1 is 7 micro. And then we have the distance, which is 0.4 square. Okay. So this is R1 lah. Sebab this is the distance from point P to charge 1. So this is equal to 393.75 kilonewton per coulomb. And then solve for charge 2. This is 9, 5, 6. This is 0.3 square. No, that's not 0.3. This is 0.5 square. So this is trigo. So this should be just 0.5 meter lah. 3, 4, 5. Dia punya trigo punya pair. So if you don't remember that, you can also just calculate calculate dia punya value lah using trigonometry. Okay. Right. So next, just calculate that. You'll have 180 Newton per coulomb. Newton per coulomb. Alright, after cari dia punya magnitude untuk each charge, we can then solve for x and y component lah. Okay, so untuk x component, you can either do this using a table, but I'm just gonna do it directly lah. So this is EX. So this is equal to E2x je. Sebab E1x is equal to 0. I'm just going to do it this way lah. So this is 0 plus E2 cos theta. Oh, we forgot to calculate theta. I forgot to calculate theta. So basically theta is going to be here because my theta is here. So this is tangent theta because opposite over adjacent, which is 0.4, 0.3. So shift tangent 0.4 over 0.3 will give you 53.13 degree lah. Okay. So this will then give you 108 times 10 to the power of 3 Newton per coulomb. Okay. Untuk y component pula, so EY is equal to E1y plus E2y. So E1y is just E1 and E2y is negative E2 sine theta. Why is it negative? Because this is pointing downwards. E1 is positive, sebab dia point upwards. E2, when we resolve into its y component, it will be pointing downwards. Please remember that, because that is from our semester 1. So this is 249.75 kilonewton per coulomb. So after that, we have to resolve this. EY square. Okay, so dari sini kamu akan dapat 272.1 kilonewton per coulomb. And then don't forget its direction. So that is shift tangent EY over EX, which gives you 66.6 degree. Okay, so this is below positive x-axis, below pala. Above positive x-axis, because this is positive, this is also positive, so it's above the positive x-axis lah. Alright, okay, so that is on example 1, example 2, and example 3, and basically on subtopic number 2. So for this subtopic, you have to be able to sketch the electric force diagram, electric field string diagram. So contoh positive, negative, it will be and then at a point, contohnya point di sini lah. Okay, so this will be like this is gonna be like that. So this is Q1, Q2, this is E1, this is E2. Okay, next you have to find the magnitude lah. Magnitude of the electric field string, and then if ada x and y component, you have to find the magnitude and the direction lah. Okay, so it can be x and y. Yeah, so that's basically for subtopic number 2.